Hello and welcome to Barklund Labs. Today we are talking about the reaction rates lab, and normally in these lab videos I like to cover four things. Number one, safety. Number two, the procedure and things to be careful about. Number three, any concepts we were learning about. In this case that would be how reaction rates affected by temperature and by particle size. And number four, what control variables I want you to watch out for. Now I'm not really actually going to talk about 3 and 4 in today's video because number one, I want you to discover what the relationship between temperature or particle size and reaction rate is. So how does the temperature of a reaction affect how fast it goes, or how does the temperature, or how does the particle size of a tablet affect how fast it reacts? That's number one. And then number two, the big overarching thing of this lab purpose is to talk about experimental design. So independent, dependent, and control variables. So I'm not going to tell you what the control variables really are. I want you to watch out as you're doing this lab and kind of jot down and write down and think about what are some of the things that you want to keep consistent throughout the entire experiment. What are the things that if you weren't very careful to control and do the same would give you bad results? There's a couple big ones, and we'll see if you can find them as you go along. So number one, safety. The biggest safety thing has to do with our Bunsen burner. Obviously the Bunsen burner is a flame. Ladies, you need to make sure that you have a hair tie. I think I told most classes, just find a spare one and stick it into your science binder. That's going to be a good way of always having it whenever you need it. Number two, don't wear any really droopy hooded sweatshirts or really drapey sleeves that could potentially get caught in the Bunsen burner if you put your arm near it. So clothing and hair, got to be careful with those. Obviously, just don't do anything dangerous with a flame. But the other main safety concerns have to do with what the flame is making hot. So you will have it underneath here. This is a ring stand and a wire mesh. The ring is going to get really hot. The wire mesh is going to get really hot. The Erlenmeyer flask is going to get really hot. So one of the sayings I have is cold glass looks just like hot glass. Cold metal looks just like hot metal. So if you come over to somebody else's lab table and grab their Erlenmeyer flask, you might be grabbing one that was just boiling and burn yourself. Gotta always put your hand near it before you touch something, or touch something really carefully if you're trying to check to see if it has cooled down. Another safety concern, by the way, I have burned myself on these wire meshes before. This is to help support the Erlenmeyer flask. You get a really cool little pattern on your thumb or on your finger. Maybe you don't want to find out firsthand, but it'll burn this little waffle kind of thing on your thumb. Like I said, I have done that. I probably have made most of the mistakes that I'm going to warn you about in class this year, and hopefully you can learn vicariously through me. So, another safety concern. We are dealing with glass. You do not want to break an Erlenmeyer glass, and if you do, you need to let me know right away so we can get that glass taken care of and it's not going to hurt anybody or cut anybody. The most likely way that it would get broken, besides just somebody being careless and dropping it, is the collar on here on the test tube clamp. You want to tighten it enough where it's snug. So right about here, you can notice that it's not moving around, but it's not super tight on there. It's not. I've had people snap a neck on there before because they tighten it so much that it just squishes that glass in there. So you've got your Erlenmeyer flask in there. You'll use your graduated cylinder to measure out a certain amount of water. Add the water to your Erlenmeyer flask, and then you light your Bunsen burner. And what I recommend is do not light your Bunsen burner underneath this whole setup. Get it lit first. Adjust the flame so it's a nice, smaller cone, and then you can adjust the height of this. So oftentimes we'll do that first, then that, and then you can place it underneath there. You don't want to have to adjust this once it's hot. I can help you with that if need be, but it's not very easy. So get everything adjusted and ready to go first, then start heating. So you're gonna get, we've got some nice long stem thermometers here. You can take the temperature of your reaction. I'll let you decide what temperatures you're shooting for. The big thing to be careful with here is to not just sit here with your thermometer in in the Erlenmeyer flask. There's a lot of heat going around there, and I've had students actually melt these in the past. Maybe I'll show you one that got melted 2 years ago. So please be careful to not just leave it in there, only put it in there for long enough to let the temperature stabilize. And I'll talk about a note about the stabilization really quickly. You'll notice that this is not an instantaneous thermometer. What I mean by that is I'm putting my hand on there. You notice the temperature keeps on going up and up and up and up. You do not want to record or write down that temperature until it actually stabilizes, until it reaches a point where it's no longer oscillating, going up, going down, until it's just reached a pretty steady temperature. So obviously, for my hand, it should get somewhere in the 90s. So you'd want to wait until it gets to that point before you let it go, or before you write that down. So you get to your whatever temperature it is that you want to get to, you turn your gas off, and then you grab your Alka-Seltzer tablet. Use a timer, use those little red timers you've got, drop your tablet in there, and then wait till it's done reacting. I'm going to let you decide when it's done reacting. Is it you can't see any bubbles anymore? Is it when all the white powder is gone? I'll kind of let you make that call. But you're going to time that. And then you're going to do the whole thing again, but you're going to go to a different temperature, either warmer or cooler, and you're going to try a set of different temperatures and see how that affects how long it takes that Alka-Seltzer reaction to occur. That's one experiment. We're doing a totally separate experiment. It's related, but it's really like two experiments in one, because now we've got a new independent variable. For our second experiment, we're not using the heating setup at all. You're just using the Erlenmeyer flask, and you can use that razor that the scalpel kind of thing you might have seen me cutting, X-Acto knife, cutting up the Effordent tablets with, and you're gonna go from using a full tablet to a tablet in quarters, and then finally you'll use the mortar and pestle to smash it up into a powder. What you're doing is you are breaking up the number of particles that make up the tablet. You're not changing the amount of the tablet. You should still, if you quarter it, you should still use all 4 quarters, or when you powder it, you should still use all the powder, but you're changing how large the particles are that make up that material. And then you're gonna do the same thing where you add it to a certain amount of water and see how fast that reaction occurs, and then you'll do that at those 3 or maybe more different levels of particle size. So that's the procedure, and you're welcome if you want to try something, thinking a little bit outside the box that I don't put in the procedure. You're welcome to try it. I usually have 1 or 2 groups who want to do that every single year. So let me know if you'd like to try something else. And like I said, I'm not going to really talk much about the science. We already talked about how Alka-Seltzer tablets work. It's an acid and base reaction producing carbon dioxide. And then the science of the reaction rates is what you're going to learn in the lab. So that is about it.